All right, welcome. This is the lecture on soil. So, whether you're doing this on your own or you're finishing up the lecture that was started in class, this is just a great resource for you to be able to go through your materials and make sure that you have everything that you need in your notes about soil formation and composition. And so, this you should be able to find your notes on soil formation and composition in I think this year it's page 30. Um, but I just want to make sure like you find the page that this one is supposed to go on. Soil formation and composition. Soil is um, a place where the geosphere and the biosphere intersect. And so we're going to discuss this as part of your target. Your target asks you to discuss the interactions between all four of the spheres, especially in terms of like how erosion and weathering really work in ecosystems. And we're transitioning from learning a lot of things about earth science, tectonic plates, the rock cycle, and we're moving into applying what we know about the earth science aspects into how that translates into creating the ecosystem. We're going to take a lot of time speaking to what ecosystems are, how they function, how they're structured. And as we know, we've talked about this, um, energy is finite. Our energy source comes from the sun, and the biological organisms need energy. And we have one awesome pathway for capturing that energy that we are very aware of, and we know that photosynthesis is this incredible pathway for capturing that energy. Well, for terrestrial systems, land systems, soil is a crucial aspect of this process. We start with an understanding about where soils come from originally, even by talking about tectonic plates and the process of erosion. We've talked about the rock cycle. It's all going to really tie in when we begin to talk about soil and how that transitions into an understanding of ecosystems. So, first of all, we're going to talk about how soils are formed. Soil is formed from the weathering of parent material. That would be the rock. And we've talked a lot about different rock and how rocks, even, like with a rock cycle, or where does it come from originally? Kind of like the, like the most fundamental place that we see rock formations, coming out of the ground, right, as lava is in volcanism. And there, so we can kind of start there with that context and know that, like, if there's some kind of expulsion from a volcano, or maybe it's just a magma moving up within the lithosphere and maybe cooling underground, that there's going to be a rock layer in the lithosphere that contains the cooled components of the magma from beneath the crust. And this parent material really actually forms the crust, but it's all like this like continuous cycle and process. And the parent material is that original rock. It happens to be right in line with what we were talking about in terms of weathering. Weathering is a breakdown of this rock. Now, like if we kind of go with this concept of like starting with the original material, the igneous rock, you may have a big slab of rock that's pretty solid. You can think of, granite slabs, like, El Capitan, or like big mountainous areas that have like big rock formations that are igneous rock formations. Those are kind of like, that's where I like to think of that as like, that's like the original rock. And then that rock is going to break down. A big solid mass of rock is what actually becomes sand, right? And so it has to go through a process of breaking down. We've talked about this difference already. Erosion is the movement of sediments. weathering is the creation of sediments. So there's two categories that process can fit into: either physical weathering, which is a process that breaks down rock into smaller pieces, or chemical weathering that uses reactions, chemical reactions, or this is where they occur. It's not like it's accessing them or something, but it's just like chemical reactions occur, and those chemical reactions break down rock. Soil is an aspect of nature that incorporates all four of the spheres. So soil contains minerals, that's part of the lithosphere. It contains water, that would be part of the hydrosphere. It contains pockets, pores. There's spaces between particles, and that's very important for root systems. So roots have to get down in between all of those little pores and find nutrients, oxygen, be able to pull up water through roots. And so it's really important. Like oversaturated areas have to have special adaptations within roots that are actually populating soils that have like a high saturation of water, because we actually need spaces between particles, and there's got to be gases in there. There's actually air. Plants actually need air, and you can drown a plant. If you look at the window, I added a little bit too much water to a plant, or somebody did, to one of my plants, and I lost a plant this year, and you can see it sitting in the window. And I was hoping maybe a little bit of it would kind of grow back, but it got oversaturated and it drowned because the roots were underwater. There are also, biological components to soil. Plant roots, obviously, but beyond that, there's a microbe, like a colony of microbial organisms that really create the power of soil. We categorize soil in something called a soil profile, and this is an example of a soil profile. So you can see, I'm moving myself down here, like this lower level it is a different color than this level here, right? And that is an indicator of different components being present in those layers of soil. So this is called a soil profile. We call those different layers horizons, and they are really determined by the composition of the soil and what's actually in that soil. So here is an example of how we kind of split that out. Soil horizons have not every soil is going to have the same proportions of these things, but they should have some of this. Obviously, deserts are going to have a lot less organic material. Rainforests are going to have a lot of organic material. So O is the top layer. This is where plants are going to be growing, and they grow into that organic matter, but they also die and create that organic matter. And then right below that would be topsoil, organic matter that's mixed with minerals. The alluviation layer is this like dry, barren layer. It's not always present in the soil horizon, but it needs to be defined that this is an aspect of soil horizons that can be present. This is an area where water has leached through and nutrients and minerals are moved into lower layers. And that's actually like kind of a layer of soil that's pretty poor. And then there's a subsoil where there's higher levels of minerals and nutrients. And then below that, we have the parent rock. This will be slightly weathered bedrock. And then below that, we have bedrock. And the bedrock is the solid parent material. So this is like the original. That's the OG rock, okay? That hasn't gone through weathering. But everything that has weathered and moved and then things have grown, it's been stacking on top of this bedrock. Soil is... So it's really complicated, and it has a living component, but on the rock side of things and on the lithosphere side of things, soil can be categorized by the size of its particles. So the sediments themselves are categorized into three distinct components that are based on size. The smallest particle will make clay. The next size up we call silt. And above that is sand. Anything bigger than sand, that's gravel, right? And that's rock. So we wouldn't call it soil if it's rock. So clay is like, you've seen this kind of like probably at the river, Sacramento River, like you step on it, it's like sticks to you. Silt is a little bit bigger than that. And obviously, we know what sand is. Each of the three components have particle shape and properties that contribute to whether or not water can move through that soil and how much air is actually going to be contained in that soil. So it contributes to the drainage of that soil. The heaviest soils have, or I'm sorry, the healthiest soils have a mix of all three. There's a component of organic matter that can be mixed into soils, and we'll still call it soil. So there's like a little bit of a or ambiguity between the particles themselves, just talking about particles and particle size. But know that soil is living, it's super duper complex, it's made of weathered and possibly eroded sediment materials, and it's worth studying, but we absolutely need it. It takes a very long time to build up soil for ecosystems, especially in areas that are dry or hot, like deserts, where we don't have a lot of biological material and where decomposition may happen a little bit slower. And then we know that like each area in the world, we kind of live as humans, and sometimes we use soils in a way that can do damage to that soil itself. So this is the next topic that we'll be covering coming up. So summary: soil is formed by the weathering of parent rock. Weathering can occur physically or it can occur chemically, and soil is categorized by its composition. So if that bedrock is there and we're just interacting with weathered material and organic matter growing in that weathered material, you don't actually have erosion. You just have weathering, where things are breaking down even more. And sometimes the biological components are actually breaking that material down even more. Soil is categorized by its composition, and each soil horizon has a unique makeup. And everywhere in the world, because of the differences in heating and location on the globe, has a different soil horizon, as different soil profile based on differences in the bedrock and differences in that parent material. Each soil, where are we? Soil particles come in different sizes, and the size of these particles can impact soil composition. So something new. I'm sure you haven't spent that much time thinking about soil before, but we will be talking about soil a lot in this class, including the next lecture. So get all of this information down, and then remember that what I expect you to do is interact with the text that you have now created. You have notes, they are guided, but you need to be able to go back and add on anything that I said, like examples or explanations that aren't in the notes that you feel would be helpful for you. Add those in, highlight the parts that are important, make sure that what you have in your notes answers the question that's in your left-hand column. Fill in your summary. You can even add on more to a summary, add a sticky note to it if you feel like that's something that's going to help you really deeply understand this topic. Remember, what I'm really looking to see is you gain skills, that you learn to study and you learn this material even though you probably never even thought about soil this much before. All right. Have a good weekend, because you're going to be doing this on Friday or maybe on Saturday, but you're definitely not waiting till Sunday night. And if you are, be better. All right. Have a good one. I will see you Monday. Remember that we have a vocab quiz on Monday. If you are watching this and it is fall of 2025, you have a vocab quiz on Monday.